Here we are taking an example. The example is related to differentiability. How to differentiate a function by definition. Since we are taking over here example, and by example we will explain that either a function is differentiable or not differentiable. The example of the function is given by f of x. This is equal to x square and sine of 1 over x square sine of 1 over x and 0. So this is when x is not equal to 0, x is not equal to 0, and this is when x is equal to 0, and we want to check the differentiability at x is equal to 0. So now we are taking the solution. I am extremely sorry over here if you are listening the voice of my children, of my wife. So extremely sorry for this. So let we move towards solution. Okay. First of all, we will find the left differential. The left differential will be found just like as f prime of 0. F prime of 0 means that it will be equal to, by definition, limit, and here you will take h approaches to 0, and also it is actually f of 0 minus h, 0 minus h, and minus f of 0, because the value of a over here is actually 0, f of 0 by definition, and simply this is a minus h means that 0 minus h, and after putting the value, this is limit h approaches to 0, which is just like as minus h square sine of 1 over h, sine of 1 over h, and minus 0 divided by minus h, and after simplifying, this will be equal to limit h approaches to, remember that we are finding the left limit, 0 minus, and limit h approaches to 0 minus, and this will be equal to h sine of 1 over h, and after simplifying, we will get, after applying the limit, we will get 0. Okay, now we find the right limit, right differential. What is the value of right derivatives? This was the left derivative, and so right derivative will be equal to f prime of limit h approaches to 0 plus, and this is f of 0 plus h, and minus f of 0 divided by it is equal to h plus 0 plus, and this will be equal to h square sine of 1 over h minus 0 divided by h, limit h approaches to, and after simplifying we will get limit one over h, and after applying the limit this is 0. So this means that both values are same, 0. So left derivative f prime of 0 plus is at 0, 0 plus at or simply you can say f of you can also write just like as it is prime f prime plus at 0, this is equal to f prime left differential at 0 are same. So this implies that the given function is differential. F is actually differential at x is equal to 0. At x is equal to 0.